Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my video channel on YouTube where we talk about everything I want to that's science and math related. And what we're going to talk about right now is chemistry, and we're going to start talking about bonding. We've gotten to the point where we want to learn, we've learned about the atoms, we've learned a lot about them, we've learned about ions and isotopes, and now it's time to find out about how they get together. So we're going to talk about the two kinds of bonds, one in this chapter and one in the next. And what we're going to talk about this time is ionic bonds, okay? So first of all, we have to know about something called valence electrons. So the valence electrons are the electrons that are on the outside of the atom. We can get rid of that physics. They're on the outside. I've also heard it called something else. Martha Stewart says something different instead of valence. I forget what it is. Anyway, your pronunciation may vary. I call it valence electrons. So they're the ones on the outside. So like if you have some really big element like cesium, then all of those elements that are down close to the nucleus, they're not going to do anything. They're not going to react to anything. It's the ones on the outside that can come in contact with other atoms or other situations. They're the ones that are going to be the ones undergoing chemical reactions and bonding. Now, so I brought my periodic table, and I need to bring one from school. I found one that I have at school that I don't really like. It's too small, but it'd be perfect for this class and for videos. So I'm going to bring it home, and then if I'm making, or leave it at school. But anyway, it's going to become the video periodic table because I have two, in case you haven't figured this out, I have two chemistry channels. I've got one that is primarily for homeschoolers going through the lessons, but sometimes I'll assign these videos, and that's what this one is, but sometimes I'll assign these videos to my public school kids too, because chemistry is chemistry. It doesn't matter who you are or how you're learning it, right? So this could be, you could be watching this as one of my public school students, or you could be watching this as one of my homeschool students, but it's the same topic, valence electrons. But but where I'm going through the book, going over every single thing in this book, is called Lessons of Chemistry, and that's what this is. The one where I make videos absolutely targeted for the public school kids, and I say things like, make sure you get that worksheet done. That one is called Elements of Chemistry. You get it. So anyway, so sometimes I will assign my public school kids not only elements of chemistry, but especially if they're out and they needed a bigger picture, I would assign these videos too. So don't let that confuse you that there's two different channels. And a lot of them will say the same thing, because like I'm teaching ionic bonding to you guys this week and to them next week. So I'll probably make them another video, or maybe the week after that, because we have winter break coming up. Ooh. But I'll be making another video about the same topic. So you can watch them both. There is nothing to stop you. They're all public. They're all on YouTube. You watch whatever you want, because you just can't get enough of my videos, right? Okay. Anyway, so how this works. On the periodic table, depending on where the elements are, remember how we learned how Mendeleev told the elements where to go? Who told the elements where to go? Mendeleev. So he is the one who discovered the periodic table first, and then Henry Moseley rearranged it by atomic number. But depending on where they are on the periodic table, they go about getting happy different ways. Now, what do I mean by that? It all really has to do with energy, but we're going to just pretend that these little elements have feelings and that they have desires. And their desire is to be like the ones right over here. This last column is called the noble gases. And the noble gases are fat and happy because they have full outer energy levels. They have full valence electrons. So helium is the smallest one, and its outer energy level is full with 2 electrons. And we'll learn more about why. We're going to learn about the SPDs and Fs and things like that. But we'll learn about why it's just got 2. But all the rest want to have 8 for their outermost level to have a full set of 8. And the noble gases have the full set of 8. So they're not looking to have a reaction with anybody. They're happy how they are to get it. We used to say they were inert, meaning they don't react. Now we figured out we can force them to react sometimes, but they are unreactive in nature. They are happy the way they are, no reason to react. All the other elements on the periodic table, all these other rows want to be like the noble gases and feel like they have a full energy level. And they do that different ways. And one way is by forming ionic bonds. It's what this chapter is about. Okay, so let's talk about how that happens. In this column right here, they have one extra electron in their valence electrons than the noble gases. If they could lose that one, so like sodium's number 11, if it could lose one, it would feel just like neon that has 10 electrons in its outermost energy level. So sodium wants to get rid of that extra electron so it can feel like neon. Next to it is magnesium in column 2. Column 2 has 2 extra electrons it wants to get rid of so that it can feel like neon. If it could just lose 2 electrons, it would have 10. It would have just the perfect number, 8 on the outside, and it would be happy. Okay, so what I say is that you can think of these as parents. And these are the bad parents who leave their kids at Walmart, drop them off at the fire station, abandon their children. It's because the electrons are like their children and they want to get rid of them. They want to, feel like they're single again and have no children. Now, of course, all of this is really bad, but it's just going to help us remember it. Okay, so over here, this column right here, the one next to the noble gases are the halogens. And they have 7 in their outermost level. So they are just desperate to get one so that they will have 8. So over here I have chlorine. And if it could get just one more, it would feel just like argon, because it would have the exact number that argon has and be just like them. So I say that this is like how, especially people in England, they all want to be like William and Kate and the prince and princess and have all the cute little children, or else they want to be like a Disney princess. Everybody wants to be royalty. Okay, so everybody wants to be like the noble gases. And why? Because they have full valence levels and it makes their energy feel good. Okay, so these are the crazy parents who go to the hospital and try to steal a baby. There's people who do. So this column, they want to steal 1 baby. This column wants to steal 2, and this one wants to steal 3. This column wants to lose 1, that one wants to lose 2. We skip these in the middle, and this column right here with boron at the top, they want to steal 3. Okay, so that's the stealing thing. Now, when my youngest, Joshua, was a baby, when he was born, no big shock there. And when you have a baby at the hospital, they put this thing on them that's like baby LoJack, because people really do. They'll dress up like a nurse and try to come steal your baby out of the hospital. So they put this thing on it where you can't take the baby past the doors or the hospital will shut down and all the doors will lock, meaning someone's trying to steal a baby. So they have this baby LoJack on them so nobody steals your baby. I was very paranoid. I did not let my baby out of my sight. I didn't trust the baby LoJack, and I was very protective of my babies. Well, at 10 days old, he almost died. He got RSV, this bad lung infection thing, and he had to go to Scottish Rite, which is one of the children's hospitals here in Atlanta. And he had a 50-50 chance of living, so he's on the you can't breathe baby ward, and he didn't have baby LoJack on him. And I'm asking the nurse, what about baby LoJack? What if someone comes in here and tries to steal him? And the nurse just laughed at me and she said, honey, nobody wants your baby. He's broken. He's sick. Nobody's taking him out of here, because if he did, he'd die. And nobody wants a dead baby. And I remember going, I want my baby. He might be broken, but I want him. Anyway, he got better. He's a teenager now, so he's all better. So that was really good that he made it. But I was very grateful for Scottish Rite, but woo, that was something. So anyway, all of the babies on the periodic table are not broken babies And somebody wants these electrons. One of these elements want them. Okay, so we have our crazy ones over here. So a lot of times what they do is they work out a trade. Adoption. Better than leaving your baby at the fire station, right? Let somebody adopt him. So these parents over here, these guys, will lose their electron. This column will lose one. And when they do, remember, electrons are negative. They lose one piece of negative, which causes them not to have balanced charges anymore. And they have a charge now of +1 because they lost a piece of negative. These guys, when they lose their electrons, remember they want to lose 2, they get a charge of +2. And this column right here, when they lose all 3 of their electrons, they get a charge of, yes, you guessed it, +3. Okay, now these guys over here, when they give up their electron, they will gladly take it. So chlorine is just dying for one. It'll work it out where sodium will give its electron to chlorine. And then chlorine has an extra piece of negative, so it gets a charge of -1. The second column where oxygen is, these will get a charge of -2. And the third column where nitrogen is gets a charge of -3. And so you've got positives and you've got negatives. And what do opposites do? That's right, they attract. There used to be a Paula Abdul song. And I would tell you to go watch the video on YouTube. But the wolf smokes in it. And nowadays you're not supposed to advise people to go watch smoking. But it's something about opposites attract. And I always want to sing it. But then I started singing a different song. And I think another artist totally ripped off her song. But anyway, it's got a video of Paula Abdul from American Idol a long time ago singing with a cartoon wolf about opposites attract. So if your parents were like kids in the 80s, they might know that song. Or I think it was in the 90s. It might have been in the early 90s. Anyway, so they get together. And so that when they do, because opposites attract, they stick together. It forms ionic bonds. They're formed by electrons transferring and opposites attract. So sodium loses its electron, chlorine gets the electron, sodium becomes positive, chlorine is negative. They get together and you have NaCl, sodium chloride, which is table salt. So these ionic compounds have certain characteristics. And you can think of salt. This is your classic ionic compound. They're solids, they're crystalline solids, they're brittle. You put them in water, they dissolve, they conduct electricity. So you'll need to learn those properties. Okay. Ionic compounds, properties of ionic compounds, they make crystals. Okay, now the book goes ahead and talks about metallic bonds. So what about these metals in the middle here? Okay, they're not the bad parents leaving their baby at Walmart. They're not the crazy parents stealing somebody else's parents. Or good parents giving their baby up for adoption, good parents adopting the baby. Everybody can be good in my periodic table parental rights world. What about the metals? The metals here in the middle, things like gold and silver, platinum, copper, and nickel. They're right here in the middle. What they do is they are too far from the ends to think that they can steal or lose electrons enough to feel like a noble gas. So what they do instead is they do something called metallic bonds. And I say they're the hippies. When I was a kid in the 70s, there was this ideal world. It takes a village to raise a child. And these hippies would all go live together in a hippie commune. And they would have kids. And the kids would end up calling all the women mom and all the men dad. And I saw videos of this. And these kids were usually dirty, running around barefoot, crazy hair going everywhere, no rules, and it was considered the very best way to raise a child. And you hear it in a lot of songs from that time. There's a song talking about called In Seattle, and it says, growing up like a child, beautiful and wild in Seattle, free and wild in Seattle. You hear it in the song Born Free. There was all this idea of children running around with no rules, no shoes, no bath, that was the natural best way to raise a child in these communes. But now some of those kids have grown up and written books, and I don't think it was good at all. So there was a girl who ended up in the she was a murderess. She wasn't. She turned evidence. Anyway, there was some murders that one of these hippie communes did back, and it was the Charles Manson. He was crazy. He ran a hippie commune like this. They had the kids running around everywhere, all crazy. Well, there was a girl who was part of that, and she ends up turning state's evidence. But before she was in the hippie Manson commune, she grew up in a different hippie commune like this, and till like they kicked her out when she was 14. But anyway, she has written a book or done a documentary or something, and her childhood was terrible. Those people were just crazy, thinking that that was the best way. But for metals, it's just fine. So that's what the metals do. What they do is they don't assign their electrons to any particular nucleus. They allow the electrons to run around like a beautiful child, free and wild, in between the atoms and just have a great old time. And because of these free electrons just going wherever they want, these metals are good conductors of heat and electricity. They're shiny, reflecting light. Everything that glitters isn't gold, but it's got free electrons just running around. So that's what they do. They're the hippie commune parents. They just share their electrons between all of them, have a good old time, and conduct heat and electricity. Now, the last group we're going to talk about next time is this group right up here, and these are the divorced parents who have custody arrangements, and they share their electrons. So we will talk more about that next time. Now, it does talk a little bit in your book about the electron configurations of these, and it's just showing how, you know, the 1s2, 2s2, and then comes 2p6. It's just showing that it's those that the noble gases have the full valence electrons, which are reflected in their electron configurations, where the ones who don't have full electron configurations, you can tell it, you can tell they don't have full valences by looking at their electron configurations. So take a look at that, and like, share, and subscribe. Come back next time, and we'll talk about the divorced parents, covalent bonds. All right, science is great.